Hey, good morning, everybody. This is Mr. Ainsworth here, and we are going to go through a lesson on how to graph linear functions in standard form and how to change them to slope-intercept form, the form that you guys are probably really familiar with. So there's two methods to graph a linear function in standard form, and standard form is right up here at the top. It's ax plus by equals c. So notice that y is not isolated. And what we want to do is get it in slope-intercept form of graph is one method, that's method two, and then method one is using intercepts. And using x and y intercepts is actually a really cool method. It's used in many different classes in upper level math, and it's actually quite easy because it's using the number zero, and zero is always easy to deal with. All right, but you have to understand how to get x and y intercepts first. So once you have your document in uploaded into OneNote from Canvas here, okay, slide on over here and let's draw an XY coordinate plane and give it a little title here, finding x and y intercepts here, and let's just find out a quality that all x and y intercepts have. Okay, so we're going to start off with y intercepts first, points where the function crosses the y-axis. Okay, so here you'll notice that I'm going to start picking some points. So follow me, okay, and set up the axis here, positive if needed here, and go at your own speed. Okay, so here we go. I'm going to plot a few points. So 0, comma 1, that's up 1. Okay, so up 1 is 0, comma 1. That's a y-intercept because it's on the y-axis. All right, and 0, comma 2 is 2 units up on the y-axis, and 0, comma 3 would be 3 units up on the x-axis. And if you can plot 0, 0 if you like, that's a y. That's both an x and a y-intercept, okay, because it's on both axes. All right, 0, comma negative 2. Well, guess what? That is on the y-axis as well. All of these points are y-intercepts, and if you go for it and you get crazy here, 0, comma negative 4. That's on the y-axis as well. And these are all y-intercepts, okay? Y-intercepts, okay? Points where the function may cross the y-axis. And the question is what do they have in common? And if you just look at it here, yeah, they're all on the y-axis. That's pretty obvious. But and when you take a look at the coordinates, okay, and every point has an x and y coordinate right here. So an ordered pair, let's just talk about it. Ordered pair here. Ordered pairs, ordered pairs, all right, come in the form of x comma y, as you guys know, and the x coordinates first and the y coordinates second. And so you'll notice here, it's hopefully pretty obvious that they have the x coordinate the same. They're all, okay, they're all x equals 0. So the way we find y-intercepts, okay, our method here, so y-intercepts are found, write this down because this is the key concept here, okay, are found by, okay, substituting, okay, substituting 0 in for x, so x equals 0 here, all right, and solving for y. Oops. And solving for y, which happens to be the y-intercept, okay? And you're going to see me do that. So substitute 0 in for x, solve for y, and you get your y-intercept. All right. Now the other way around, if we reverse the process right here, let's take a look at some x-intercepts, okay? So I'm going to plot 4, comma 0. Ooh, that's thick here. So 4, 4, comma 0, that's 4 units right on the x-axis here. That's called an x-intercept. Why? Because it's on the x-axis. Okay, it's that simple. All right, and then 2, 2, comma 0, well, that's 2 units, right? Negative 2, comma 0, that's 2 units left. Negative 4, comma 0, that's 4 units left. And if you go 6 units left, that's at negative 6, comma 0. And then you got to ask yourself, what do these points have in common? And it hopefully is obvious that they have the y coordinate. They're all 0, guys. Okay, so when you want to find x-intercepts, okay, like the ones I just showed you right here, so let's write this down. X-intercepts, when you want to find them, okay, they're found, oops, getting a little crazy here, are found, all right, by substituting 0 in for y. So substituting y equals 0 in the function here and solving for the x coordinate. which is exactly what we're going to do. Okay, so if you understand what I just said right through here and you know the difference between x and y intercepts here, then what we're about to do is fairly straightforward. So let's go back to the lesson here, and I'm not going to do all of these. I'm just going to do probably around 3 just to give you an idea, and then of course you can do the rest. Okay, why? Because you need practice. Okay, I've already been through it. Okay, and I've already had plenty of practice, and now it's your turn. All right, so we have this, we have standard form here of a linear function here, ax plus by equals c. Okay, so a times x plus b times y equals c. So notice y is not isolated here like you're used to seeing. Okay, it's not in slope-intercept form at all. But in this form, it's super easy to find x and y intercepts, and I'm going to show you how. Okay, so the first thing we want to do is we're going to substitute 0 in for x and solve for y. This is called the y-intercept. Okay, and then I'm going to substitute 0 in for y, and I'm going to solve for x, which represents our x-intercept. So one at a time. So first we substitute 0 in for x. So here we go. I'm going to just bring this function down. So 2 times 0 minus 4 times y equals 8. Okay, well, we know this is fairly straightforward, right? Anything times 0 is 0, so that's 0. And 0 minus 4y is negative 4y. And you got to think, okay, negative 4 times what number equals 8? And so you want to just think about it, like, what is this number here? And if you think negative 4 times negative 2 is 8, okay, then you know y is negative 2. Now, if you need to show some thinking here, so if you want to divide by negative 4, that's fine too. Okay, and you'll still get 8 divided by negative 4 is still negative 2, and that's called the y-intercept. And then you plot your points, okay? Plot. So 0 comma negative 2 is on the y-axis. Again, y-axis is on the vertical, your x-axis is on the horizontal, okay? And so then you plot a point. 0 comma negative 2 is down 2. Okay, next, okay, now you substitute 0 in for y. Okay, so now we have 2x minus 4 times 0 is equal to 8. Okay, so now I substitute in 0 in for y and you solve it. Well, anything times 0 is 0, so that cancels out. All right, negative 4 times 0 is obviously 0. And then you have 2x equals 8. And then if you just think about it, 2 times what is 8? And the answer is 4. Okay, because 2 times 4 is 8. So now I have my x-intercept. And now I just plot that. And of course, you graph it and you draw your linear function. So just get a ruler out and draw a line through those 2 points, because it takes 2 points to determine a line. All right, and that's why this method is used, because people that are experienced with this can actually do it in your head. You substitute 0 and you think about it and you get the other value. All right, it can be done mentally, and that's why it's used so often. All right, whereas if you isolate y here, okay, and get it in slope-intercept form, which is your famous y equals mx plus b. We call that slope-intercept form because m represents your slope, or what's called the rate of change, and your b represents your y-intercept. Hence the name slope-intercept form, because it gives you that, guys. It gives you the slope, or what's called the rate of change, as you guys know, and then the y-intercept. Okay, so notice that the y-intercept is negative 2 already. We already know that, because we solved for it earlier, and we already know the x-intercept because we solved for that earlier. And that's also just where the line crosses the x and y axes. Okay, that's why they're called intercepts. They're on the axis. All right, so now let's take this function over here and let's solve it. Solve for y. So we have 2x minus 4y is equal to 8. All right, first step, you add the opposite. In fact, let me just bring this over here. You have 2x minus 4y equals 8. All right, my first step is you add the opposite, and the opposite of 2x is negative 2x, so I'm going to add that, okay? So add the opposite. I'm going to write down some steps here. Add the opposite. Step 1, okay? Well, the reason why we do that, my friends, is because 2x minus 2x is 0. All right, opposites always add to 0. And then you bring down your term and you get negative 4y equals. And here you can write it as 8 minus 2x, or you can write it as negative 2x plus 8 because 8's positive. And I typically write the x term first because your goal is to get in a slope-intercept form where customarily it's m times x plus b. So the x term comes first. And then step 2 in red, I'm putting all the steps in red. Step 2, this is negative 4 times y, so you always do the inverse, and that's called division. So you divide all three terms, okay? So step 2 would be to divide by whatever the coefficient of y is, okay? So step 2 is divide. And it's the same steps every single time you do it. So all of these examples are going to be the same. Add the opposite, divide. Add the opposite, then divide. I mean, it's pretty straightforward. So we have y is equal to negative divided by negative is a positive, so cancel out these negatives here. 2/4 is the same thing as 1/2, so you have 1/2 x. 8 divided by negative 4 is negative 2, so you have negative 2. And notice that's the y-intercept, which is seen on the graph. And your slope here, what's called the rate of change, is 1/2. Okay? And that's also called rise over run. It's called the slope, it's called the rate of change, it's rise over run. And you see that up here. You can see the slope. You go up 1, right 2, up 1, right 2. Or you can go up 2, right 4. You can do that too. Even in the table, if you calculate delta y, negative 2 to 0, okay, delta y is equal to 2 there. From 0 to 4 is plus 4. That's your delta x. This is all I'm doing using concepts from the past. And the rate of change here is always delta y divided by delta x, which is 2 divided by 4, or those 1/2. And guess what? That is seen in the function right here, 1/2. So you can see it in the table, you can see it in the function, you can see it in the graph. You can see it three different places, all right? And that's the beauty of this. Like you need to be able to see the rate of change of the slope in all three forms of the function, which is the ordered pairs, the table. You see it in the function itself, y equals 1/2 x minus 2. And you also see it in the graph when you look at the rise and run. Okay, up 1, right 2. Up 1, right 2. Okay, so draw the slope, and when you see it here, go from one point to another point. Okay, up 1, right 2, up 1, right 2, up 1, right 2. It keeps on going. And it's constant because it's a line. It's a straight line. All right, the slope or the rate of change does not change for linear functions. All right. All right, so let's get some more experience here because one example is not enough. So let's repeat the whole thing and obviously look at what we just did in order to do the second one. Okay, and when it comes to videos, guys, if you're watching this at home, you should be pausing, pause, play, and you should be going at your own pace. And you should also, all right, rewind when you need to hear it again. You have to use the technology properly, all right, and use it properly. That's basically it. All right, so number 2, we got 3x plus 5y equals 15. All right, and you want to find the y-intercept first, so you let x equal 0. And when you solve for y, you're getting the y-intercept. All right, so here we go. So 3 times 0 plus 5y equals 15. Well, that gives you 5y equals 15, and I think you know that 5 times 3 is 15. So y is 3, and there's your y-intercept. So you plot it. So you go 3 units up on the y-axis at 3, and there's your y-intercept. Now you find your x-intercept. And you let the y value be 0, and you repeat the process. Okay, so here we go. So now you have 3x plus 5 times 0 equals 15. Well, 5 times 0 is 0, so you have 3x equals 15. And I think you can do this in your head, I hope, right here, that 3 times 5 is 15, so x is 5, and that's called the x-intercept. So now you plot them, okay? You plot 5, 0 on the x-axis, you plot 3 on the y-axis, and you draw your function here, and you have your heavy linear function, okay? Now, check this out. Right off the bat, I see a rate of change. I see down 3. Notice I put a negative there, and I see right 5. Okay, and we have rise over run. So my rate of change, okay, is down 3, right 5. Okay, and that's called the slope of the graph here. You can also see that in the table. From 3 to 0 is a minus 3. There's your delta y. From 0 to 5 is a plus 5, and there's your delta x. And the rate of change is always delta y over delta x, as I've been saying ever since the beginning, okay, almost daily, okay? And you have negative 3/5 here. So notice that the rate of change in the table is the same as the rate of change in the slope on the graph. They are the same. And if they aren't, that means you made a mistake, okay? Now, when you take your function over here off the right, method number 2, and you solve for y, we should get the same sort of thing. So 3x equals, or plus 5y is equal to 15, okay? And just like before, you look at the example before. It says step 1, add the opposite. Opposite of 3x is called negative 3x. So we're adding a negative 3x to both sides, and the opposites cancel to 0. They always cancel to 0. And you get 5y is equal to negative 3x. Okay, put the x term first, plus 15. If you wrote it as 15 minus 3x, that's fine. All right, but I always put the x term first just to make it look nice. All right, and then you divide. Step 2, divide. Look at the previous problem. Step 1, add the opposite. Step 2, divide. So now divide by the coefficient of y, which is 5. And you divide all three terms by 5. Okay, so now you have y is equal to negative 3/5 x. There's your rate of change. 15 divided by 5 is 3. So you get your rate of change or the slope first, and you get your y-intercept next, which happens to be up there on the y-axis. Okay, and everything matches. The rate of change in the table of negative 3/5 matches negative 3/5 in the function, which matches the rise and run on the graph in the graph. Okay, and everything correlates together. Okay, it has to make sense. If they don't, that means you made a mistake somewhere. And that's how the game is played. All right, I'm going to do one more, and then you guys can do the rest for practice. All right, because listening and copying for me doesn't help you any, but practicing and at home and developing your skills does. Okay, does matter. Okay, so here we go. We've got a function right here. Okay, so we have, let me see here. So we have, we have x minus 2y equals 4, right? And the first thing we do is we find the y-intercept by letting x be 0. So we do that. Okay, so we have 0 now. 0 minus 2y equals 4. Again, we substitute in 0 for x and solve for y. Well, I just get negative 2y equals 4. Divided by negative 2 gives you 4 divided by negative 2. So y is negative 2. All right, negative 2 times negative 2 is positive 4. So I have my y-intercept. So you plot it. So go to the graph, go down 2, and plot it on the y-axis because it's a y-intercept. Y-intercept is on the y-axis. Okay, get that in your head. All right, and now next we have, you have to put in 0 in for y now. And then you got to solve for x, which gives you your x-intercept. All right, so here we go. So we have x minus 2 times 0 equals 4. Well, that just gives you x equals 4. All right, and so you plot that. So 4 units right, and there you go. You got your line. Okay, there you go. And you can see on the graph, if you go from point to point, you go up 2, okay, and you go right 4. So I can see that my rate of change or the slope is rise over run, 2/4, 1/2. Okay. You can also see that in the table. From negative 2 to 0 is a plus 2. From 0 to 4 is a plus 4. Right there. And so my rate of change in the table is delta y, again, divided by delta x, and that gives me 2/4 or gives me 1/2. Same thing. Okay, so they match already. And that's a good thing, because if they did match, okay, obviously we're doing something incorrectly here. Okay, so now let's isolate y and get it in slope-intercept form, which is y equals m times x plus b. You got to isolate y. Isolate y means, well, it means isolate y. It means get it by itself, all right, and have it y equals something. All right, and so it's like isolating a variable, whether it be x or y, is important. It's an important skill, a basic skill in mathematics. Okay, you can't go into higher mathematics without knowing some basic algebra stuff here. Okay, so here we go. Now follow the steps from the first example, okay? All right, it says add the opposite, step 2, divide. Well, you do the same thing. And the opposite of x is negative x. So you add a negative x to both sides. There's your step 1. All right. Now, or you can think subtracting x, that works too. It's the same thing, by the way. And then here, okay, these cancel to 0, right? Opposites always add to 0. And then I've got, well, I've got negative 2y is equal to a negative x plus 4. If you wrote down 4 minus x, that's cool. Step 2, divide by the coefficient of y, which is negative 2. All three terms, by the way. Common mistake is people don't divide all three terms by the coefficient and they get the wrong answer. So make sure you're dividing everything by negative 2. A negative divided by a negative is a positive. And so I get here, I get negative x divided by 2 gives you 1/2 x. Right? 4 divided by negative 2 is called negative 2. And there we go. Rate of change is 1/2. Your y-intercept is negative 2, which is seen on the graph. Okay? Okay, all right. And so everything matches here, and you are set. So there's 3 examples. Everything is done the same way. The rest of them are practice, and you could check everything online because my solutions are online. So get an idea of what it means to be an intercept and apply it through your lessons and get good. And the only way you get good is through proper practice, okay? Perfect practice, okay? Let's write this down. Perfect. Okay, not practice doesn't make perfect, but perfect practice, all right, makes perfect. All right. So that, people have said something similar to this in the past. You've heard people say practice makes perfect. Well, if you don't practice in the right way and you're making mistakes all the time, you're getting worse, people. So practice doesn't make perfect, but perfect, okay, practice makes perfect, which means that you have to check your work for quality, okay, and make sure that you're doing the right thing. All right, because if you're not, you're actually gonna get worse than how you start. Okay, so use the videos effectively. I upload my solutions online in Canvas, and you have all kinds of resources. So do the right thing at home, and you're gonna get good. All right, guys, I'll see you in class. This is Ainsworth. Bye bye.